question 22 states the physician orders heparin IV to infuse at 750 units per hour. The solution strength is 25,000 units of heparin in a 1 liter bag of dextrose 5% water to calculate the flow rate in milliliters per hour. I guess that's 5% dextrose in water. That's what I should say. But anyways, okay. So when I do these problems, I'm going to set it up very similar to how I would set up my heparin protocol, in that I would start with what is the current flow rate. Current flow rate is the 750 units per hour. Okay. And that's what it states in the problem. And then what the question is asking is to convert units per hour to milliliters per hour. So I'm going to do that using the IV that they gave me. And that IV contains both things that I need. It contains units and it contains milliliters. Okay. It contains 25,000 units of heparin and it contains 1,000 milliliters of the 5% dextrose water solution. Okay. And so I'm just going to multiply across the top, divide by the bottom. And what I'm going to get is, plug that into my calculator, 750 times 1,000 divided by 25,000. And that'll give me 30 milliliters per hour. So again, the trick, I would say the trick or the strategy for this question is start with, make a decision what you want to start with. I decided that when I do these types of problems that I'm going to start with the current rate, units per hour, and then I'm just going to convert units to milliliters using dimensional analysis. There's no like, I'm sure you can figure out a formula or something like that that would work with this. But this is how I'm explaining it based off of, like I said, dimensional analysis. I feel like that's probably makes, at least visually makes the most sense, so we could see everything and we don't confuse where things go, which I think is a common problem with questions like 22, 23, and 24. So 23, I'm going to do the exact same thing. So the first question I'm going to ask myself is, what is the flow rate? The flow rate is 1,250 units per hour. Okay. Then it says the IV is 500 milliliters, 5% dextrose, water with 25,000 units heparin. So I'm just going to do the same thing. I'm going to convert units to milliliters. Those of you who heard me on my soapbox before with dimensional analysis, one of the reasons why I like to show this is because even before I do any kind of math or even before I put any kind of numbers, I at least know I'm setting it up right. Because if I'm looking for milliliters per hour, and if everything's set up like that, then I know that my answer is going to be in milliliters per hour. So it takes the guesswork out. You might have to guess what these are, but if you listen to how I'm talking through these things, I think it's helpful. Plus, it even states it in the same line that in your IV, you have 500 milliliters and then 25,000 units. So it tells you everything, at least it's supposed to tell you everything that's in there. Then I'm going to plug that into my calculator. So 1,250 times 500 divided by 25,000. And we're going to get 25 milliliters per hour. And then 24, again, following a similar strategy. But this time they talk about insulin instead of heparin, but insulin and heparin are both measured very similarly. They use units. So it says that the current flow rate is 15 units per hour. Times. And then I just look at to see how is it available? Like what is it coming from? What's in the IV? Well, we have 100 units of regular insulin in 500 milliliters of 0.9% normal saline. 500 times 15 divided by 5 or divided by 100. And I'm going to use my calculator again. So 15 times 500 divided by 100, it's going to give me 75 mil per hour. So again, no trick necessarily, just this, this is the strategy I use for all of these questions. Start with units per hour, start with the flow rate, convert the flow rate from units per hour to milliliters per hour using dimensional analysis. If you have another way that you're doing these and you're getting that, then you're getting the right answer, you're doing it right. Okay, so my way is not the only way, but you might find that out soon. Yep, you're welcome. Yep, sometimes it's helpful just to see, what it looks like. Include this with basic unit conversions. When you're going from like milligrams to grams in this example, you do not round your answer. Okay, the only time you would round a conversion is when you're doing something like different units. So this is metric milliliters going to standard ounces, or pounds standard to kilograms metric. That's the only time you would do rounding for basic unit conversions. But when you go micrograms to milligrams, milligrams to micrograms, grams to milligrams, milligrams to grams, do not round your answers.
Okay, thank you.
Yeah, you're welcome. And that was a very good question, by the way, because a lot of times that's where people mess up, is they're like, okay, well, they told us to round to the nearest 10th. That really applies for everything from like question 5 and down is where those apply. Your basic unit conversions, do not round those.